Hi and Assalamualaikum. We are from Group 8. We'll be presenting on the question 8 for the assessment 2.
Question 8A. Construct a 1 minus alpha % confidence interval for the standard deviation sigma for a random sample of size n from a normal population with unknown mean and unknown variance. So, the foundation of this confidence interval relies on a crucial result from statistical theory. If Xi follow normal distribution with mean of mu and also variance of sigma squared, then the statistic n-1 S squared over sigma squared follows a chi-squared distribution with n-1 degrees of freedom. To construct a confidence interval, we need to find two critical values of the chi-squared distribution, which is chi-squared with the degree of freedom 1 minus alpha over 2 and also n-1, and chi-squared alpha over 2 n-1, such that the probability of the chi-squared statistic falls between these values is 1 minus alpha. These values define the lower and upper tails, which each containing alpha over 2 of the probability. So, the third step is we invert the terms, and it's because we want to isolate the sigma squared. We first invert all the terms in the inequality. When inverting an inequality, the direction of the inequality signs reverses, as you can see here. So, the next step is we need to multiply all parts of the inequality by n-1 S squared to isolate sigma squared in the middle. As you can see here, this is the working method. Since we want the sigma to isolate by itself, we take the square root of all parts of the inequality. Since the standard deviation is always non-negative, the inequality signs remain the same. As you can see here, this is the working method. So, the last one, based on this derivation of confidence interval for the population standard deviation sigma, is given by square root of n-1 S squared over chi-squared alpha over 2 n-1 and also square root of n-1 S squared over chi-squared 1 minus alpha over 2 n-1. This interval provides a range of values within which we are 100% 1 minus alpha % confident that the true population standard deviation sigma lies.
Next, question 8B1. Given that let x1, x2 until xn be a random sample of size n from gamma 2 and 4 over beta squared. The equation asks to show that the distribution of a new random variable w equals to summation of xi times with n times with x bar over 2 has a chi-squared distribution with 4n degree of freedom and x bar equals to summation of xi over n. To answer the question, step 1, we need to extract all the information given in the question. So from the question, we can see there is 3 important information. The first one is given that summation of xi follows gamma, 2 and 4 over beta squared. The second one is given that w equals to beta squared over 2 times with n and times with x bar. And lastly, it's given that x bar equals to the summation of xi over n. The second step is to state the MGF of x. Since we know that x follow gamma distribution, therefore we can take the MGF from the gamma distribution and substitute the information given. The third step is to find the MGF of w. In order to find the MGF of w, we must state w in the MGF form, where m, w, t equals to the expected of exponent power of t w. Next, we need to substitute w with its function. Then, we substitute the function of x bar. Next, we expand the summation of x into x1 plus x2 until xn. Since we have exponent with the power of function plus, we can separate the exponent from x1 until xn. Next, we separate the expected from x1 until xn. Now we have MGF of w equals to MGF of x1 times with MGF of x2 until xn. Then we substitute the MGF of x, and since that all the MGF is the same, we we can conclude that the MGF of W equals to 1 minus 4 over beta squared times with beta squared T over 2 to the power of negative 2n. Now that we have the MGF of W, we need to compare the MGF of W with a suitable MGF for special distribution. After the comparison, we find that MGF of W is the most suitable with the MGF of chi-squared distribution. So hence, we need to compare both MGF of W and MGF of chi-squared distribution. So, from the comparison, we need to find the degree of freedom, which is B. So after the calculation, we obtain that B equals to 4n. Lastly, we can conclude that W follows chi-squared distribution with degree of freedom of 4n. Therefore, the answer is shown.
Assalamualaikum. My name is QISTINA binti Mohamad. Next is for question 8, B, 2 Roman, which is construct a 100 in bracket 1 minus alpha % confidence interval for beta. So for the step 1 is extract all the information from the question, which is first is W equals to chi-square distribution with 4n degree of freedom. And the second one is W equals to beta square and x bar over 2. Both of them is come from the question B, first Roman. Then for step 2 is write the general equation, which is P in bracket chi-square with degree of freedom 1 minus alpha over 2 4n less than W less than chi-square with degree of freedom alpha over 2 4n equals to 1 minus alpha. Next, we substitute W equals to beta square and x bar over 2 into the general equation. And then we got assertion, which is P in bracket chi-square 1 minus alpha over 2 4n less than and equal beta square and x bar over 2 less than and equal chi-square alpha over 2 4n. So, to find the confidence interval for beta, we need to multiply by 2 for all the chi-square distribution. And then we got as below, which is P 2 chi-square 1 minus alpha over 2 4n less than beta square and x bar less than 2 chi-square alpha over 2 4n. After we multiply with 2, we will divide the probability with n x bar. So, we will get the P in bracket 2 chi-square 1 minus alpha over 2 4n divided by n x bar less than and equal beta square less than and equal 2 chi-square alpha over 2 4n divided by n x bar equals to 1 minus alpha. Since the question need confidence interval for beta only, we need to square root all of them to get only beta. So we will get P in bracket square root of 2 chi-square 1 minus alpha over 2 4n divided by n x bar less than and equal beta less than equal square root 2 chi-square alpha over 2 4n divided by n x bar equals to 1 minus alpha. Therefore, the 100 in bracket 1 minus alpha % confidence interval for beta is square root of 2 chi-square 1 minus alpha over 2 4n divided by n x bar less than and equal beta less than equal square root of 2 chi-square alpha over 2 4n divided by n x bar. For the last question, which is B 3 Roman, if n equals to 10 and submission of xi from I equals to 1 to 10 equals to 100.5, obtain the 90% of confidence interval for beta. For the first step, we will extract all the information, which is first n equals to 10 and then summation of xi equals to 100.5. Alpha equals to 0.1. Alpha over 2 equals to 0.05. And the last one is 1 minus alpha over 2 equals to 0.05. Next, step 2, which is this is only the additional step. We will substitute x bar that equals to summation of xi over n into n multiplied with x bar, and then we will got n in bracket summation of xi divided by n, and then for both of n that equals, we will slash both of them, and then we will got summation of xi. From the question, we know that summation of xi is starting with I equals to 1 and n equals to 10. And then summation of si that I equals to 1 and n equals to 10 is equals to 100.5. And then we continue with step 3, that we will substitute all the value that we already extract. So, square root of 2 chi-square 1 minus alpha that equals to 0.05 and 4n that equals to 4 multiplied with 10 divided by n x bar that equals to 100.5. Less than and equal beta less than and equal square root of 2 chi-square alpha over 2 that equals to 0.05 and 4n that equals to 4 multiplied with 10, and the last one is n x bar that equals to 100.5. So to calculate the 90% of confidence interval for beta, we will substitute the chi-square 0.95 and 40, and the second one is chi-square 0.05 and 40 from table 8, and we will get square root of 2 in bracket 26.509 divided by 100.5 less than or equal beta less than or equal square root of 2 in bracket 55.759 divided by 100.5. Then the interval that we got for the question is 0.7263 less than and equal beta less than equal 1.0534.